All right, so we stopped at 38. So this next thing is under like another new heading. Write each expression in factored form as an algebraic expression of a single trig function. So that means that we're going to be factoring. So we are used to factoring like x squared plus 2x plus 1 or whatever. We factored that before. Well, now we're going to be doing that, but with trig functions. So number 40 is 1 minus 2 sine of x plus sine squared of x. So we need to factor this, but for most people, at least initially, it's harder to think about having to factor with trig functions. So we use something called U substitution, which I may have shown you last year, not with trig, but with something else. I can't remember, but anyway, so U substitution, not let, I don't know why I wrote let. Now, let U equal sine of x. So that means that anywhere I have a sine of x, I'm going to replace it with u. So like sine squared is going to be u squared, so on and so forth. So I have 1 minus 2u plus u squared. Now, for most people, they prefer to factor when it's in like standard form. So we could rewrite this as u squared minus 2u plus 1. So now, in that form, how would you factor this? What? Yep, u minus 1 squared, because this is a perfect square trinomial. So now, the only thing that we have to do is we have to remember, I've got to plug this back in. So this becomes sine of x minus 1 squared. And that's our answer. So you don't have to use U substitution if you can see what the factored form would be without it. But I know for a lot of people, it's easier to see with things like x's or u's or whatever, like we've been factoring with for all of time. Let's see. Uh, 48. So this one is write each expression as an algebraic expression of a single trig function. So we've got tangent squared of alpha minus 1 over 1 plus tangent of alpha. Anybody recognize what the top kind of looks like? So my first thought would be, okay, is this an identity? Is there an identity where tangent squared minus 1 equals something? Or one that can be manipulated that way? So tangent squared minus 1 is secant squared? Well, what is that identity? So I can't change this to be equal to secant because this is 1 plus. Both things would have to be negative, and I can factor out a negative, but I can't do that with this one. So a Pythagorean identity doesn't work, so I'm going to see if I can factor. Does this look like anything to you? Or maybe if I instead wrote it as u squared minus 1, how would you factor that? Yep, u plus 1 times u minus 1, it's a difference of squares. So I can do that same thing with, it'll just be tangent instead of u. So on top, it'll be tangent of alpha plus 1 times the tangent of alpha minus 1 over 1 plus tangent of alpha. So now, tangent of alpha plus 1 and 1 plus tangent of alpha, because those things are being added, they can cancel. So I'm just left with tangent of alpha minus 1. All right, one more that's a little bit different, but same kind of process. Tangent squared of x over secant of x plus 1. So at the moment, I don't really see any way I can factor this. And there's nothing I can cancel, but I know that this isn't as simple as possible because otherwise they wouldn't be giving me this problem. So, is there something that I can rewrite maybe? So I could, but is that going to help me cancel anything? So is there something else I can rewrite? So that's true, but again, is that going to help me cancel something? So it's a Pythagorean identity, so I would say try to rewrite it because, and the reason I say that is because I know that the tangent squared would be, whatever you said, secant squared minus 1. So that means that both things are in terms of secant, which is good. Now, not to say that I won't have to do something else also, but at least I know both things are in terms of secant. I'm more likely to get something to cancel. So, this becomes secant squared of x minus 1 over secant of x plus 1. Now, similar to what we did in the last problem, what can the top part factor into? So it won't be squared when we do that, but it is secant plus 1. Secant of x plus 1 times, can't write, secant of x minus 1 over secant of x plus 1. So the secant of x plus 1's cancel, and I'm just left with secant of x minus 1. So these problems, especially the part that we're doing today, is going to require you to think a lot more. So you may try something. You may rewrite tangent as sine over cosine, and you may be like, well, that didn't help me, and then you're backtracking and you're doing it again. This isn't something that typically just like clicks overnight. You're typically trying different things until you get down. So that's why you have a lot more problems assigned to you for this section, and even the next section you'll have probably a little bit more than normal, just because if you don't practice these ones, you're going to struggle to see how can I rewrite things and using your identities. All right, then last thing in this section is, what number is that? Taking the square root of a trig function. Okay, so this is a little note that you probably didn't have in your notes. The square root of trig functions must be positive so they need to be written in absolute value bars. This ultimately is like one of the easiest things. It's just you have to remember to put your answer in absolute values. So number 70, we've got the square root of x squared plus 1, and they tell us that x is equal to tangent of theta. Now, why they don't just go ahead and put tangent of theta in there to begin with, I don't know, but that's how they give you the problem. So the first thing we do is we replace x with tangent of theta. So this is the square root of tangent squared of theta plus 1. What's tangent squared of theta plus 1? Secant squared. So this is now the square root of the secant squared of theta. Square root of a square is just the function itself. So this is going to be secant of theta. But it has to be positive, and when we take square roots, obviously we can have positive or negative. So I've got to put it in absolute value bars, and that's your answer. All right, one more, and then we'll be done. 72, the square root of 36 minus x squared, x equals 6 sine of theta. So notice with this one, 6 sine of theta is all being squared, okay? So this is the square root of 36 minus 6 sine of theta squared, and I normally wouldn't necessarily write this step, but I want you to see it, that the whole piece is being squared. So then this becomes 36, all under the square root, minus 36 sine squared of theta. At this point, both of these pieces under the radical have a 36 in them, so I can factor the 36 out. So this will be 36 times 1 minus sine squared of theta. Well, what's 1 minus sine squared of theta? Cosine squared theta. So this is the square root of 36 cosine squared theta. What happens when I take the square root of that? Yep, 6 cosine theta. Now, the only part that goes in the absolute value bars is the trig function. So the 6 is outside, and we put the absolute value bars around cosine theta. Any questions on that? I know that's not something we've done before this class. All right, where did we stop on problems the other day? 37. All right, so adding on to what you had the other day, you'll just turn it all in together. 39, 47, 49, and then 69 and 73. So just a few more, which if you did problems the other day and finished them, you should be able to finish this. If you don't, it is due on Tuesday. 5.2 doesn't have any notes because the notes from this section correlate with that because it's more with identities. We'll be verifying things, so that's where we have one side equal to the other. But that's where we'll pick up on Tuesday. Trying to remember. .3 does have notes though, so that'll be probably due Wednesday or Thursday next week. Also